Hello and welcome to this step-by-step tutorial that will show you how to configure your HIL device to communicate with Modbus protocol. Modbus is an open, easy to use and implement protocol. Thanks to its simplicity, the Modbus protocol has become a standard communication protocol in the industry and is now the most commonly available means of connecting industrial electronic devices. We will go through the following steps. Step 1. Creating a new model. Step 2. Adding the Modbus component to the model. Step 3. Configuring the Modbus server. Step 4. Connecting the signals. Step 5. Compiling the model. And Step 6. Reading the simulation values using external application. First, you need to create a new model by clicking the schematic editor. Choose File, New and New Model. Choose the HIL that you want to configure, to use, and click Next. Finish. The Modbus component can be found in the library browser under Communication, Modbus device. Drag and drop this component to the schematic. This model implements a Modbus server that will be run on HIL device, with which you can access the simulation values through another third-party Modbus client application. Once the component is on the schematic, you need to configure the Modbus server. You do this by first double-clicking the component and opening the dialog window. In the dialog window, you can see a property called Modbus configuration. Here you pass the configuration that you specified. You specify the configuration inside the model initialization, which will be shown in a moment. How the configuration should look like, you can see in the dialog window. We can copy this example, click OK, then go to Model Initialization panel, where we can specify the configuration. We pass the configuration that we copied, format it a little bit, and now we can change the parameters of the server. The parameters of the server can be split into two groups. The first group is the network configuration, the second group is the register map configuration. For the network configuration, we specify the Modbus port 502, the default port value. We specify the server IP address, net mask, and slave ID. For the register map, we specify the addresses of the call registers, discrete input registers, holding registers, and input registers. For this example, we will use only input registers. We can delete the holding registers addresses, and now we have only input registers specified. Every register is 16-bit in Modbus application. So basically here we have 25 registers defined, all 16-bit length. We can further improve the implementation by combining 2 or 4 registers with square brackets to form a 32-bit registers, and again we can specify type of that registers to be I for integer, U for unsigned integer, and F for floating point. Let's say we use 3 32-bit floating point registers. So we create 3 groups of 2, like so. The other registers will delete. And now we've created 3 32-bit floating point registers in the register map. Click OK, and now we configure the Modbus server. The next step is connecting the inputs of the Modbus to the simulation. For this example, we'll use simple constant values to show the functionality of Modbus. So in the model library, search for constant, signal processing component, and put it in the schematic. Since we defined 3 registers, we will need 3 constant blocks. To connect all 3 blocks to the register input, we need a component called bus join that creates a vector output from scalar inputs. Double click the bus join, set number of inputs to 3, and connect constants to this block. Now at the output of bus join we have a 3 vector value of 3 scalars connected to register in. That's how we connect simulation values to the Modbus registers. All the other outputs should be terminalized by using termination block for the outputs, like so. And using constant again block with the value of 0 for all the inputs that we are not using, like so. And that's it. We are now ready to compile the model. To compile the model, click on the compile and load icon at the top of the window. First, we need to save the model. For example, set the name as you wish and save the file. Now the model is compiling. It is shown in the window below. To read the simulation values, we will use a third-party application called Modmaster. This Modmaster can be downloaded from the browser. By searching on Google, it will be first result. Let's see the basic overview of Modbus Master application. To establish the connection with the Modbus server, we only need to configure the address of the server. Set up the protocol to TCP, and that's it. We only need to start the simulation. We'll just create a new panel, run the simulation, and click on connect. Once the client is connected to the server, you can choose which function you like to perform. At this point we want to read input registers, select that function. Specify the start address of the registers, 0, and number of registers. We specified 3 32-bit registers, that's 6 16-bit, and we can specify the format of the registers here. We will leave a decimal. Once we selected all that we want, click on scan. Here we can see the values that we read from the client. Basically, we read the 32-bit values, and once we combine these two values, we get the values that we specified in the simulation.